Okay, thank you. I'm glad everyone is enjoying the networking. So do appreciate you coming back on time. So I'd like to continue with our next presentation entitled CFX Reflow Soldering. And the presenter is Marc Peo of Heller. Would you like me to read your bio or we'll just go right in? Okay, so Mr. Marc Peo began his mechanical engineering career at Lehigh University in 1977 and has joined Heller Industries in '83 to lead the transition of the company from through-hole to the growing area of surface mount technology. In his 30-plus years at Heller, Mr. Peo has been involved in the development and implementation of several successful SMT initiatives, including adhesive transfer, vertical curing, solar panel processing, and the convection reflow soldering system that are now the industry benchmark. Marc has been involved in IPC SMEMA Council, also on IPC Board of Directors, and is currently one of the co-chairs of the CFX committee. Marc?
Thanks, Dave. So when you're with a company for 30 years, that only means one thing, right? Nobody else would hire me along the way. Gets a better laugh, usually. Hey, what's this? Is it stress ball? I'm hoping not to create any stress today. That's my point. I'm hoping that you don't need this, and I'm hoping that the presentation doesn't warrant you throwing them at me. So please, let's try to keep these under control. Just throw one, I'll get the idea. So we want to talk today about CFX, and the idea is that Industry 4.0 is something that everybody's talking about, right? Industry 4.0 this, Internet of Everything, blah, blah, blah. But it seems sort of like a buzzword, but it's nothing really tangible. And what I wanted to talk about today is the notion that Industry 4.0 is not only something tangible, it's something that you can implement and use right now in the form of the IPC CFX Standard. For a lot of companies, the Industry 4.0 implementation seems like a large mountain to climb. For small companies, it's, oh, you know, I don't have the resources for this, what's it gonna get me back? For large companies, oh, it's gonna be millions of dollars. So the idea today is to talk about the questions, the variables, the costs, and to answer some of those questions and give some clarity to Industry 4.0 as it applies to electronics assembly, but in particular reflow. Because we like the reflow example because the reflow oven is pretty much the most boring thing on the line. And to be able to show the information that you can get out of that shows you just how powerful the CFX can be in the assembly process. And then it shows you that the other pieces of equipment can really expand on that and provide value to you as a printed circuit board assembler. So the IPC Connected Factory Initiative, CFX, I want to give you a little bit of background. I think everybody here, your companies are probably members of the IPC, but I'm not sure everybody understands or knows that the IPC is a member-driven organization. So the IPC, Dave Bergman doesn't wake up and go, hey, what kind of standard can we make for somebody to buy? He sits back and waits for the phone to ring and waits for people to call in and say, hey, I need this. And the CFX was really born from the customers, the members of the IPC, saying, we have a bunch of equipment that all speaks different languages. They don't talk to each other. The screen printer doesn't talk to the conveyor, doesn't talk to the pick and place, doesn't talk to the oven, doesn't talk to the AOI. They all have different languages. And in fact, all the vendors are actively trying not to talk to each other by creating proprietary languages that you have to pay money for. So the manufacturers were fighting it, but the customers were saying to Dave and to the IPC, we need this. we need to create a communication link that allows me to have traceability, to have host computer connectivity, to have data analytics. And so the IPC took on the job of creating the CFX standard. So this is a member-driven, customer-driven item. So how does the CFX work? Well, it allows for plug-and-play data content definition. There's a defined language content. The messaging is very simple. I'll show you that later. The communication protocol is highly secure. The group chose AMQP because it's used in the banking industry and it's great for security, and all the data is encoded using JSON. So it's a very simple, simple setup. So it's a plug and play. It's an open consensus-based, whoops, wrong button. Come on back. There we go. 300 different participants, 300 companies participated in creating the CFX standard, which, by the way, was published in April of this year. So it's real, it's live. There's no licensing required, there's no contract, there's no dependencies, and it facilitates this machine communication. Why is CFX different than any other standard? There's plenty of standards out there, right? Is this just going to be another one? Well, what CFX does is it provides the same physical connections between the equipment. So there's reduced implementation cost and time. It gives the same data content for all the equipment. So the messaging is consistent and you get greater value for the data. No dependencies on third party, especially middleware. This is a big cost-saving aspect of the CFX, is that you don't need all this expensive middleware to make the machines communicate with each other. And there's no hardware or licensing. It's very easy to use. And if you wanted to modify it for your own data streams, that's fine too. It allows the ability to be modified, so it's not that firm where it can't be modified. In terms of the adoption and the integration, we offer open source SDKs free of charge from the IPC. Again, this is not a moneymaker. This is a way to satisfy the member need. The group has been able to demonstrate CFX on hundreds of different machines. And this allows your business to enable the Smart Industry 4.0 goals. It's fully scalable. And what we wanted to do is we wanted to say, well, yeah, but does it really work? So we went ahead and at the Apex show in 2018, we put together 2 full assembly lines at the show with all these different partners. And 2 lines were set up and running within 4 days. That's how easy it is to implement and how easy it is to coordinate a line assembly. And at the show, we also enabled mobile access to the CFX, and you can do it right now on your cell phone. You can see a line running live on the connectedfactoryexchange.com, where every 20 seconds or so a board goes in and you get a data stream talking about takt time, yield, failures, uptime, downtime. This dashboard's available right now through connectedfactoryexchange.com. There's another standard out there called Hermes. And the question is, well, do these guys compete? Are they friends? What's the deal? And actually, they're very complementary. The Hermes standard is really a SMEMA replacement. So what SMEMA does is SMEMA says, hey, upstream machine, are you ready? Yeah, I'm ready. Okay, send me something. You can send anything you want at that point. SMEMA doesn't care. What Hermes does is it says, hey, are you ready? Yeah, I'm ready. What do you have? I have this board. oh, well, that board needs this, 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 and this. Let me see if I have that. Okay, that'll work. Send it to me. So what the Hermes does is it allows you to qualify what's coming down the line so that you can't have somebody come in with a rework board and just shove it in the middle of the line and send it through. It also enables you to have the consistency in terms of data and traceability as the product goes down the line. So the easiest way to look at it is Hermes is as an inline communication. Machine talks to machine, talks to machine. And CFX is a host-computer communication where the individual machines talk up to the host, transfer data back and forth that way. So everybody here knows, the benefits of host-computer interfacing. Central control, you get a lot of good data and traceability. In terms of the hardware side of it, there's an app interface, and CFX doesn't necessarily limit you to one thing. So you can use REST, MQTT, AMQP as your communication link as well. We support all the different protocols. And also, from the equipment manufacturer side, if you're using SexGem or some other standard, that's also supported as well, so it's not exclusive. But for anybody that's done SexGem, you know that the manual is like this big, and it's rather complicated, where the CFX is about 37 pages, and the messaging is very simple. So it's a much different animal. In terms of communication, the endpoint or the piece of equipment on the line goes up to the host and says, hey, I'm here, I'm connected. The host says, well, who are you? The machine says, oh, I'm this guy. It says, well, tell me more about yourself. I give the line information, the machine information, all of that, and then I'm ready to have activity back and forth. Load a profile, download a recipe, provide data back and forth, whatever, and then at the end, hey, I'm shutting down, fine. So the point of this slide is to say, it's a very simplified process. The idea of CFX was to make it easy. It was a KISS principle approach, and to get you the data you need, but not overwhelm you with the implementation. One of the things that's really powerful that the CFX group did was to create a messaging reference. So this is an interactive piece, and I'll jump to a different slide. Hang on one second. So this slide is allows you to say, well, I want to write a message for a particular machine, and I want to know how to write that message. So how do I do an activate recipe request? Oh, that's the message for activate the recipe. Very simple, very short, very easy, and it applies to all of the machines. This particular spreadsheet across the top talks about all of the different production machines and the messaging that's available for those machines, from the pick-and-place machine to the screen printer to the oven, and these are all the messages. You can see here, it's very simple, it's very straightforward, and whatever message that you want to send, you click on it, and it tells you how you need to configure that message. So that's one of the ways that we're able to get CFX up and going so quickly, is that for the equipment manufacturers, it really didn't take them more than a couple of weeks to be able to integrate this messaging into their systems. So we can go back here to the original. Okay. So we were talking about the boringness of the reflow oven. And you get this really interesting overview screen. It's got all this information. It's got a tremendous amount of data, but it has nothing that you can use. And so what the CFX does is it allows you to take that data and putting it into meaningful information. And so you see here that a traceability report can be easily made, showing all the zones in the machine, the barcode, the timestamp, the belt speed, and all of the actual temperatures. So board by board by board, you have this traceability. And you get not only the thermal aspects, but what was the nitrogen? Did I have the right atmospheric level? Did I have the right ppm? What was the power consumption at the time? All of this data is compiled for you. And if there's a failure or if there's an outlier, it'll tell you that as well. So very quick and very easy ways not only to get the data, but to analyze the data. You can have CPK tracking, O2 analyzer, maximum tracking, and you can get all the profile parameters reported, and in terms of soak time, liquid time, peak temperature, ramp rate, cool rate, all of these things can be reported, and then they can be compared to the baseline profile. So you can say, I got this virtual profile for my board. How did it compare to my baseline? And the software and the connection will tell you, yeah, that's a good one, or it's an outlier. There's some other powerful aspects of the CFX, and one of them is giving the ability to optimize throughput. So if I have a dual lane oven, through the CFX, I can minimize my setup time. And I can say, okay, run product down to one lane and set up for the other lane. And this allows you to see a zero changeover time from one product to the next. So one of the problems with reflow ovens is that they might take 15, 20, 30 minutes to cool down from one profile to the next, or 5 or 10 minutes to heat up to the next profile. Using this approach with the host computer interface and CFX interface, you can make it so that that's completely invisible, zero changeover. There's another aspect where if you don't have a dual lane machine, in a single lane, you can do temperature drops of 50 to 60 degrees in a few minutes using a water coil. Again, this is all controlled by the host. So it knows the next job that's coming because it's connected factory, so it knows what's coming, and it says, hey, let's get the oven working to reduce this changeover time, and let's move quickly to minimize. Also, in terms of energy management, if the line sees that there are no boards coming, you can go into a standby mode. And that standby mode will reduce the nitrogen consumption, the electrical consumption, the exhaust. So there can be significant savings in terms of operating costs as well. This one's my favorite, predictive analytics. This is really the next step, is to say, you can't really, there are two types of downtime, planned downtime and unplanned downtime. And so the idea is to eliminate the unplanned downtime. That's your big enemy. And so if I can do predictive analytics and I can look at things like the conveyor or the blower motors or the heaters, and I can sense that a failure might be coming before it comes, then during a PM, I can go and address that issue before it shuts down my line. So the idea of predictive analytics is a very powerful tool, and again, it's all part of this overall Industry 4.0 thinking. There's some conversation in the industry about closing the loop. Example, my AOI sees a defect. and it says, hey, pick and place machine, I see this defect. It looks like you put the part down wrong. Why don't you make a change? And there's some of that communication going on now in the industry where the AOI can talk to the pick and place or can talk to the screen printer and give suggestions on improvements and make the yield better. And those things are very powerful. That kind of closing the loop between AOI or SPI and the upstream machines, I think, is extremely powerful. And CFX allows you to do that. There's also some conversation about having the AOI talk to the oven. Hey, I saw a defect, change the temperature of the oven, change the belt speed, do something different. We're not for that. Basically, the oven is a mirror of what you give it. If you give it something beautiful, it gives you something beautiful back. And if you see a defect in the AOI and you try to change the reflow, that may be a defect that came from something else. And so what you've really done is created a variable where the oven is a really nice constant and it doesn't factor into any equations. If you change the parameters, it may introduce new problems, new defects, new variables. So we need some more work on closing the loop with the reflow, but we like the idea of closing the loop and using CFX for the others. But maybe we can narrow that loop. And one of the things that we've been doing is working with the AOI vendors to create a lookup table so that if the AOI sees a defect, it'll report up to you and say, hey, I saw this tombstone. Maybe it's solder quality, maybe it's solder volume, maybe it's reflow profile, maybe it's placement accuracy. It gives the line operators and the engineers some starting points for troubleshooting. And so this cause and defect relationship is something that we're starting to see implemented in the lines as well. So, in summary, the CFX unifies the Industry 4.0 landscape. It allows machines that didn't want to talk to each other to talk to each other. It can be implemented very quickly. It's complementary, it works well with Hermes, and it's cheap. I think the standard is $80. Is that right? I think so if you say, well, what's the cost to implement this thing? Okay, got to go out and buy a standard. It's $80. That's about it. The notion that these things should cost a lot of money or that you should have to do a lot of special engineering and use a lot of time, really what Dave and the IPC have done is eliminated all of that and created a standard that not only works, it works right now, and it can be implemented tomorrow. So this isn't one of those things where it's going to be better in the future when we have this. It's there now, and it's working great. And so there's a bunch of companies that are implementing this. We're going to have it at the Productronica show in November, and we'll run it live again at Apex. So we encourage everybody to look to CFX for the Industry 4.0 implementation. I think the most important message that we wanted to give is that most of your vendors are already working on it or already have CFX. So the idea is use them as the consultants for this. You don't need to go out and hire a software company to do this implementation. Your vendors will come in and show you what they need. Thanks.